Yes, good evening everyone. I hope I am audible to you. Am I?
Yes, ma'am.
Okay, thank you. Thank you for responding. Yes. So today we will be seeing week 3 summary. So we'll wait for a few minutes for more people to join. Then by 6:35 to 37 we'll start our class. Okay.
Okay,
Ma'am,
ma'am.
will you take queries from graded assignment 2?
2. Yeah, graded assignment 2 deadline is over, right?
Correct.
Yeah, sure. Then we will discuss your queries from week to graded assignment at the end of the session. Okay.
Okay.
So I will be taking class for 1 hour. Then after that 30 minutes we will be discussing all your doubts.
हो गए जमा पैसे?
Yes, the deadline is on July 1, right? So yeah, we can discuss graded assignment also. About the last surprise test.
I wanted to ask,
Hmm.
actually in the assignment they have given expected range, but if the answer is within the range, still it is given not correct for me.
Which question are you talking about?
That there were questions in assignment 1 also, and there were in the assignment 2 as well. The question
Yeah,
number
please tell
10.
me the. Okay, week 2, question number 10, right?
Yeah, week 2 question number 10 is like one of them, but there are many actually.
What is the answer?
My answer was 1.5, and the range they have given is 1.4 to 2.2.
No, it is 1.8 to 2.2.
Okay, okay, ma'am. But
Yeah.
what about the questions for the week 1, ma'am? Actually, they
Uh,
have given me 9 questions incorrect due to that, but those are within the range.
did you write the unit in the answer?
Uh, Let me check, ma'am. Yes, ma'am, I have written the unit.
You shouldn't write the unit in the. If it is, they are given the unit in the question. You should never write the unit in the answer because these are computer-based code scoring. Right? It only scores the numerical value. Whatever number you put, it will be taking it as a numerical value. If that numerical value is within the expected range, only then you will get the answer. So from next time, if there is a blank, you just fill the numerical value.
Okay, ma'am. But then now, like, even if the answer is correct, I won't be getting the marks, so will be like affected because of my qualifiers.
No, anyway, for a qualifier, graded assignment scores will not be added, right? Directly, not directly.
But the
It is
thing is,
only
they
for
have said that if I have not
eligibility.
attempted any one also.
Yes,
Okay,
the
so only for
overall, like,
eligibility.
it should be greater than. Yes. See, there will be 12 graded assignment, out of which the first 7 will be taken for eligibility. In this first 7, your average score must be greater than or equal to 40
Okay, ma'am.
out of 100.
Okay, ma'am.
Yeah.
Thank you.
So, graded assignment is for your eligibility.
Yes, ma'am. Thank you.
Yeah.
Uh, I have a question in graded assignment week 2, 11th question.
Graded assignment question number.
They have told to tunicate the final value.
Okay, question number. Please tell me the question number.
Question number 11.
11. Uh, yes.
Yeah,
In two decimal places, right?
yeah,
What
they
What
told
is your
to
answer?
tunicate. For me, I think I got the answer as 0.07. I think 0.007.
Okay.
I think
So
the
you
answer.
truncated it to.
So we have to tunicate to 0.00, right? Because
Uh, See.
if it is round off, we can make it to 0.01 or maybe something. Tunicate meaning is to cut it like remove it, right?
Okay, 1 second, let me check. Yes. Yeah, it was a very good observation. Maybe, yeah, then I will check this, okay?
Yeah, that 11th one. Yeah, I got 0.07, but many people told that 0.07 is a right answer, I think. 0.0075 or something my answer
Even if
was.
you write it as 0.007, you would have gotten correct because the range is from
But the
0.005 to
problem is
0.015.
I got
But yeah, the truncate, right? Yeah, okay.
I got
Yeah,
confused
I
with
will
the.
check this. Yes.
Thank you. Okay, thank you.
And ma'am, one weird thing that when you explain, please explain. For some of these questions, we got very specific answer. So, for example, 0.0075, but the answer in the system is a range. Like it's
Where? Which
baffling as to
question?
why it is a range.
Where?
This is a problem with a couple of questions. So I'll tell you
Yes.
one second.
See, usually how it is graded is like if your answer is a whole number, and if we feel like if while setting the question we will be knowing, right, there are one, whether it's one method or various method to solve a problem. So by solving by that particular method, and if its answer is 25, if 25 is the only way answer which you can reach, then we would have given that expected answer is 25. But if it is in decimal like 0.18 or 0.19, so just to make sure, since it is computer based, the computer will be taking only the exact value, right? So for that questions where there is a range, we will be giving expanding the range of the expected answer.
Okay, okay.
Ma'am, so what should we write in the answer? Should we write the whole decimal or the range itself?
uh, you can write the whole decimal, that's fine. Even if you write the range, you will be getting the answer as long as your range is right. See, I hope my screen is visible to you, right?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So in the question they are given it as to round it off to two decimal points. So if the answer is 0.028, you just round it off to 0.03. If it is 0.24, you round it off to 0.02. This is right. But if this in this question, if the range in the system, if we have, if if the question's answer, if even if you write it as 0.028, and in the question the expected range is like 0.025 to 0.035, then this is also fine. This is also right. The reason why we are telling you to truncate to do two decimal places is that's how we calculated the answers for these questions. Is it clear?
Yes, ma'am. It's
Yes. And make sure you don't write any units, like there will be no units in the answer. There should be no units, no commas. I heard some of you has written 10 comma 1000 like this. So you shouldn't write it like this. You just put, don't use commas. Computer will not be identify commas, right?
Ma'am, what about minus symbol?
Minus symbol is allowed. If the answer is minus 5, you have to write it as minus 5.
Okay, ma'am.
Ma'am,
Yes.
one more question.
Mm.
Ma'am, for the week 2, question number 8, uh, they have asked if charge stored in the 5 mu farad capacitor is, but they haven't given any inductor current or something like that.
Okay. Okay. Uh, in that question, they have asked actually you have to refer the diagram in the seventh question, but okay, it should have been mentioned. The diagram should be given in the eighth question also. Yeah, for this question also, I will see what I can do. Okay.
Okay, ma'am, thank you.
Yeah. So question 8, and the truth kit is one is question 11, I think, right? Yeah, question 11.
And when you solve, then question 4 also.
Question 4.
When you take the doubts later.
Yeah, sure. Yes. And have you guys watched the week 3 lectures?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes. Yes. So today is a summary session where we will be revising the concepts given in week 3. And in week 3, we will be seeing about sinusoids, then energy of time varying signals, harmonics, as well as electricity consumption at home. In addition to this, we will also be discussing about a few general topics like what is a microphone and how does it work. Then a speaker, how does it work? Then what is a motor and what is a generator, right? These are the topics which you would have seen in week 3, right? Am I missing any topic? Today, is there any surprise test? Let's see. If there is time, we will have surprise test. So the first one is sinusoids. So what is the general representation of a sinusoid? So the general expression for a sinusoid is A sine omega t plus phi. So what is this A?
Amplitude.
Yeah.
Amplitude of the function.
Amplitude.
Yes. What is
Amplitude
this?
of the wave.
Amplitude.
Right.
Angular frequency.
Angular
Omega.
frequency.
Yes, it's angular frequency. Then what is this
Angular
phi?
frequency.
Phase
Phase.
difference. Phase difference.
Phase difference.
It is not phase difference, it is phase.
Phase.
Okay.
If there is only one waveform and then we call it as phase. If we are finding with respect to two waveforms, then we'll call it as a phase difference. Okay? Yeah. Now, if I say there is a voltage waveform which is represented as a sine signal, that is V of t is equal to Vp sine omega t. Okay? And maybe we will add a phase also. Then how will the waveform be?
Sine wave displaced by some phi phase difference with amplitude Vp.
Yes. If I want to represent it in a form of graph, so there will be my y-axis, then there is a x-axis. My x-axis is with respect to time and my y-axis, it's a voltage, and let me take its units as volt. So it is in volt. It's an voltage in volts, and let me take my time is in seconds. Since it is a sine wave, it will follow a sinusoid waveform. Yes. So this will be my plus Vp and this will be my minus Vp. What is this amplitude called? Then what is this amplitude called? What is this amplitude called and what is this amplitude called? What is the
Then
first?
plus VP to minus VP is called VPP.
This first one we call it as amplitude or peak voltage.
Second one is called range.
It is called peak to peak voltage.
Okay.
So if there is a question where they have said peak voltage, then that value is from 0 to plus Vp. If they take say peak to peak voltage, then it is from minus Vp to plus Vp. This is peak voltage. This is peak to peak voltage. So these are the places where students usually get confused. That's why I'm mentioning it. Yes. Now, what is F frequency? That is represented in F, whose unit is hertz.
1 by time period.
Yes. F is equal to 1 by time period. That is right. And what is the time period in this graph?
2 pi by omega.
To complete one revolution.
Yes. Time taken to complete one complete cycle. So it will be from here to here. So from once I know this time period from this graph, I will be able to find the frequency
Frequency.
in hertz. Then how to calculate omega from this?
Omega equal to 2 pi f.
Yes. So this is one relation. This is one relation.
Ma'am,
Yes.
what is the difference between VP and VPP?
VPP. Usually this peak to peak voltage, no, they will represent it as VPP. This peak voltage, they will represent it as VP. This is peak to peak voltage. This is peak voltage. If it is peak voltage, then it is the value is from only the value of the positive cycle. If it is peak to peak, then it is the whole amplitude.
Yes, ma'am. Okay.
Yeah. Yes. Then what is a periodic signal?
Repeating on a
Which repeats in some other period of time.
Yes. So I will take the same sine wave as an example. So this is one cycle and it is repeating again. And the value at this point will be equal to the value at this point, right? The value of, let me take this as some V of t, this plus this k value, this I will take it as V plus t. These both values are same. So V of t plus k is equal to V of t. This is a general expression for a periodic signal. Now, yes, I will give you an equation. I of t is equal to 50 sine 50t plus pi by 3 into ampere. So you have to find peak value in amperes, then angular frequency in radian per second, then frequency. You can just write the answer in the chat box. Then again you have to find the frequency. Yeah, many of you are writing the answer. Nice. So the peak value, yes, many has given it as 50 amperes because peak value is the amplitude. Amplitude is this one. So that is 50. Then the next one is the angular frequency. Angular frequency means the omega value. That is omega t plus 5, right? So this is omega. That is also 50. Then what is the frequency in hertz? Omega by 2 pi. So the answer is 50 divided by 2 pi. Then what is the frequency in radian per second? Okay. Yes, right. So what most students do is here, since it is not given as angular frequency, they consider this as a frequency whose unit is hertz. So in this type of question, you have to notice the unit. With respect to the unit, you can answer the question. Okay. Then what is the phase of this question? It's this one, pi by 3. Now, in the next one, for voltage signal, the time period is 2 seconds. Yes, right. And the frequency is 1 by time period, that is 0.5. Yes, Bhavish, what is your doubt?
Ma'am, actually, in graded assignment of second week,
Mm.
I gave an answer a question in question number 11th. I gave answer as 0.00 because there.
Truncate, right? Yeah, one of your friends have already said that. Yeah, I will check that. Okay.
Yes, ma'am.
Okay. So the next topic is energy of time varying signals. So, do you guys have any doubt in that derivation, the long derivation for the energy? Do you want me to take it again, or shall we directly go to the formula and we will skip the derivation? What do you want?
Ma'am, do it again, please.
Okay. So we are going to find the energy of time varying signals. So the time varying signals is nothing but a sinusoid signal because it is varying with respect to time. It has each different value or different time. And let me take this as a DC voltage. Then there is a DC current flowing here, and R is a resistor. Now, what is the power across R?
T square by R.
Yes, it's either VI or V square by R or I square R, right? Yes, right. Now the same thing we are going to find for when there is an AC signal. Let me take it as V of t is given to the same resistor R. So since V of t is an AC signal, I of t will also become a AC signal. So let me take V of t as something Vp sine omega t. For now, to avoid complications, we will not go into the phase part. Okay, we will just see about the uh, sine wave with zero phase. Now, then I of t will be, we will just apply the Ohm's law, V by R. So Vp sine omega t divided by R. So that is equal to Vp divided by R sine omega t. So this value I will take it as Ip. So I of t is nothing but Ip sine omega t. And if I want to represent this V of t and I of t in a graphical way, what will have the highest amplitude, V of t or I of t?
V of t.
Yes, V of t. Because Vp
V
divided
of
by
t.
R will give you Ip, and R is never a negative value for now. So this is my V of t, and this is my I of t. Right. Now, if I want to find the power at any point of time, at any point, so if I say at this point, if I want to find the power, what I will do is, let me take this as instant 1. So power at that instant will be equal to I1 of t into V1 of t. That's what we'll generally represent it as. P of t is equal to V of t into I of t. Okay. Now, what is energy? In DC, let's see first. What is the energy and power relation in a DC circuit?
Ma'am, VIT,
VIT.
power into time.
Yes, and power is equal to energy by time, right? But here, since it is an AC signal and it is varying over a period of time, we will use the integral function. So the energy E is integral of P of t into dt, and I will take over one period. So it is from 0 to t. So energy in one cycle. So my E of t is equal to integral 0 to t, and I know the value of P of t is V of t, I of t. V of t is Vp sin omega t, I of t is Ip sin omega t. Instead of using Ip, I will use Vp by R. So it is Vp sin omega t into Ip, which is Vp by R sin omega t into dt. So Vp is a peak value. It is a constant value and it is not varying, right? It is a fixed value, Vp. So Vp square by R, I will take it out, and inside the integral there is only sine square omega t dt. So how will I integrate sine square omega t?
Ma'am, by changing
1
it into
minus
1 minus cos.
cos omega t by 2.
Cos 2 omega t
Just to omega t.
by 2. So Vp square by R 0 to t 1 by 2 dt minus Vp square by R 0 to t cos 2 omega t by 2 dt. Now we know what is the value of a single integral.
So cos 2 omega t is 0 in single integral.
Yes, because see, um, this is a cos signal, right? Even though its frequency is 2 omega, and
Yes.
depending on that, the time period will change. But over one cycle, we will be finding the area. So if this is one cycle, the positive area will be equal to the negative area for a cos signal. So the overall integral will be equal to 0. Is it clear? Why this cos to omega t integral is 0?
Yes, ma'am.
Because there is a positive side as well as the negative of, which will cancel each other since we are finding the area, such that the total integral is equal to 0. So my energy value is just Vp square by R. Then I can just expand it. It is 1 by 2. I will take it out. So 1 by 2. And integral of t is d, and integral will get cancelled, only t with the limits. So t with the limits t and 0. So Vp square by R 1 by 2 t minus 0. So this is the energy delivered in one cycle. So this is the energy delivered in one cycle, or energy absorbed by the resistor in one cycle. And what about the average power? Average power will be equal to energy by time. So that will give me just Vp square by 2R. Now, power in DC and power in AC. Particularly average power. What is the power in DC circuit?
V square by R.
It's V square by R. I will just represent it as DC. VDC square by R. What about the average power in AC? It is Vp
V
square
square
by
by
2R.
Square by 4.
Vp by root 2 the whole square by R. So the DC equivalent is equal to Vp by root 2. And this DC equivalent we call it as VRMS. That is equal to Vp by root 2. Right?
Yes, ma'am.
And what is this RMS? That is root mean square, which is also the DC equivalent of an AC circuit. DC equivalent of an AC circuit. Clear, right? Do you have any doubt in this energy?
No, ma'am.
Then VP is the MPP maximum peak voltage. No?
No, can you please repeat?
Then peak voltage by root 2 is the
Yes,
VRMS. No?
yes. That is a peak voltage. That is, if there is a sine wave, only this value from 0 to Vp. That is a peak voltage. So we'll go to the next topic, which is the hormones.
Ma'am,
Yes.
ma'am, if it is not a sine wave, then the RMS value is different. No?
Yes, this is the RMS value for a sine wave. It's or it will be true for some of the, other waves also. I think for a triangular wave also it is true.
Ma'am, in
Because see,
practice assignment, there are different waves
yeah,
there.
when there is different wave, you have to continue this step. See, here there is a sine wave. We applied integral for this sine wave and we found this equation, right? We whatever process we did, it is with respect to this sine wave. So repeat the same process with taking the rectangular wave. Do the integral for the rectangular wave. Do this step one by one. I think in the graded assignment or practice assignment, it is given using rectangular or some other way. That is for you to get used with the integral way of solving things. Then do the same thing. You will be able to find the RMS value. Okay.
Ma'am,
Mhm.
this is the instantaneous power.
Yes. Okay. I already told you about the instantaneous power. Instantaneous power is at a point of time. If you are taking the product of the current at that time into the voltage at that time, we call that as instantaneous power. This P of T is the instantaneous power.
Okay. V of T into
But
I
if
of.
you see this average power, this we are calculated from 0 to T over a cycle. So that's why we
Okay.
call it as an average power.
Average power. Okay. Thank you.
And if the voltage drops at a point like it was there in, I think, one of the practice questions. So if it's at, let's say t equal to 2 second, it is 15 volt and then drops to minus 10 volt. So in that case, what do you say is the instantaneous power? You take average, is it?
No, you are telling the voltage varies. What can you tell me? What is the practice assignment? So I
No,
just
no,
can read
for
and
instantaneous, you said no at a point. So
at the point.
that's what you said, right? It's the voltage at a point.
Hmm.
So if
So
it's a voltage curve, but it's a
if
DC
it is a
curve,
curve or something like this,
and it
at the
drops at a
point which you
point.
are telling,
Correct.
then you take that value.
No, so for example, if you draw a straight line from 0 to that point, and from that point, then you show a drop. Let's say it's 15 volt, and that is t equal to 2 seconds. So 0 to t, it's 15 volt. And then let's say 2 seconds to 3 seconds, it's minus 10 volt.
It's dropping like this.
I was thinking more vertical line, like a rectangular shape coming
Okay.
up.
Something like this, right?
Huh.
Then something like this. I hope so. And what do you want to find here? What is this waveform? It's
So
x-axis time. What is the y-axis?
instead of triangle, if you can just do a rectangle. So from 0, let's say it's a parallel line instead of increasing line. And similarly, the other part of it. And this point, this junction is t equal to 2 seconds. So now if somebody says, what is the instantaneous voltage at this point? What would the answer be?
Uh, at 2 seconds, it is dropping. Mm, I don't know. Most usually, you will not ask this. But okay, you want to know at 2, maybe you can either it's your assumption. You can either take this point or this point.
Okay.
Yeah.
Ma'am, the 230 volts that we get is the RMS value, right?
Yes.
So there was one question, I don't know if it was practice or something. It was mentioned that the source is 230 volts. So should I consider that as a DC source and find the energy, or I should take it as an RMS source and find the energy?
In which unit are you talking about?
The third week only, but I don't know,
Okay.
some assignment.
If it is that will depend on the question also. So this, as we said, the 220 volts or something, that is the RMS value. That is a DC equivalent value. You can either consider it as a DC value, or you can take it as a RMS value.
Okay,
if you do it both, then you will get the same answer. Because see, if you are going to consider power, if you take it as VDC value, it is VDC square by R. If you take it as RMS value, it's VRMS square by R. The same formula will get.
But then when we write it as P equals VI, then it becomes VRMS and IRMS, no? So only if I know if it is in DC or thing, I will, such a way I can change the I value.
Maybe you can give me the question number so that I will read the question, then I will be able to explain you more.
I think it's in the graded assignment, some question.
Okay. Then maybe we'll discuss it after the deadline, but okay. One second.
It's the 11th question in graded assignment.
Find the. Oh no, you have to consider it as a fixed constant value, supply voltage. Yes.
Oh, okay.
You can take it as a DC.
Okay, thank you.
Yes. Next, we are going to harmonics. Yes. There is a string that is fixed between 2 points at x is equal to 0 and x is equal to L, such that L is the length of this wire. Okay. So what if I just create a ripple in between? What if I just give a disturbance in between?
It vibrates.
It vibrates, and there are very many possible ways of vibration, right? It can go up like this, then it will go down like this. This is one possible vibration. It can move like this and come down like this. And there is also this possibility, that is x is equal to 0 to x is equal to L. Here there is a only constraint is it is fixed at this point and this point, but the ripples in between can be following different one, right? And here, okay, this is a half cycle of a sinusoid, right? We can represent this using a sinusoid waveform. So we will be just representing all the harmonics using the sinusoid. And this is the wavelength. If I represent the wavelength as lambda, what is this amplitude? Or what is this?
Lambda by 2.
Lambda by 2.
It's lambda by 2.
Lambda
so
by
in
2.
this case, the length is equal to lambda by 2. So this I can take it as lambda naught. And whatever the caused by without any ripples, no, I will call this as fundamental mode. Or you can also call it as first harmonics. And what about here? What is the lambda value?
Lambda.
Yeah,
Lambda.
actually it completes one full cycle. So L is equal to lambda. This lambda I will take it as 1. And this is called second harmonics. And what about this one?
3
So
lambda
this is
by 2.
3 lambda by 2.
Lambda.
3 lambda by 2.
So
Lambda.
this is 3 lambda by 2.
3 lambda.
3 lambda by 2.
Here the length is equal to 3 lambda by 2 by 2. So this is third harmonics. Okay. Now, we know the formula for velocity, right? What is the formula for velocity?
F lambda.
F into lambda.
Frequency into lambda.
Frequency into lambda.
Yeah. There is this formula called displacement by time. Right?
Yes.
And velocity I will represent it as V. Displacement is some distance, right? Some amplitude. So that is I will represent it as lambda. Then there is 1 by time. This 1 by time is nothing but the frequency, right?
Frequency.
So V is equal to lambda F. Yeah, you said the direct answer, it's right. But I just wanted you to know where it came from. Yes. So as we know, V is equal to lambda F. We will just keep the velocity constant and we will equate all the lambda and frequency value. So lambda naught F naught will be equal to lambda 1 F1, lambda 2 F2, lambda 3 F3 equal to and so on. Now, this lambda naught is equal to 2L F naught is equal to L F1 is equal to 2L by 3 F2 and it goes on. We are just going to find a general equation to relate fundamental harmonic frequency and uh, second, third, and we going nth harmonic frequency. So we will just first equate these two here, and we will equate this and this. So that will give me 2 F naught is equal to F1. So F naught is equal to F1 by 2. So this is equal to 2 F naught is equal to 2 F2 by 3. So F naught is equal to F2 by 3. That is nothing but F naught is the fundamental frequency. Fundamental frequency is equal to F1 is second harmonic frequency. Second harmonic frequency divided by 2. That is equal to F naught is equal, right? So I'm just say F2 is third harmonic frequency.
And second harmonic frequency by 3.
See here, second harmonic frequency is represented as lambda 1 and third harmonic frequency is represented as lambda 2. So
Okay, ma'am.
F1 is second harmonic, F2 is third harmonic. Right?
Yes, ma'am.
So, second harmonic frequencies are equal to 2 into fundamental frequency and third harmonic frequency is equal to 3 into fundamental frequency and it will go on. So I can frame a general equation that the nth harmonic frequency is equal to n into fundamental frequency. And I think this formula is very easy to remember. So nth harmonic frequency is equal to n into fundamental frequency. Okay. So I will give you a question. If the third harmonic frequency is 150 hertz, what is the fundamental frequency?
50 hertz.
Yes, right.
50 hertz, ma'am.
Yes. So third harmonic frequency is n into fundamental. So 150 is equal to 3 into F naught. F naught is equal to 50 hertz. And it is right. And we'll go to the next topic. Do you have any doubt in the harmonics?
Yes, ma'am.
No, ma'am.
What is your doubt?
Ma'am, why did you equate the velocity there?
Yeah, like all the waves will be traveling in same velocity in the harmonics. See, the fundamental concept is harmonics is just in electrical circuits. Where will this harmonics come is when there is a power line interference. You will be knowing about the 50 hertz interference, right?
Yes.
Yes. In the power line, if you use a oscilloscope to view it, there will be a sine signal you will be seeing, and its frequency is 50 hertz. But one thing that we don't usually notice is along with 50 hertz, there is also its harmonics. That along with 50 hertz, so as I said, along with the fundamental frequency 50 hertz, there is also its second harmonics that is 100 hertz. There is also its third harmonics that is 150 hertz. That will also be accompanying it together. So they will be traveling together. such that its velocity is same.
So they travel together.
Hmm. See, okay. So if I want to tell you, this is a sine wave, right? I can model it easily. Like I can write the equation for it easily. This is a sine omega t, right?
Yes.
Do you think I can write an equation for this signal?
No, ma'am.
It's difficult.
Actually,
It
yes.
is, yes,
So it
like
is
it will be like
combination
two
of
sine wave,
two.
one riding another one. Like one sine wave is riding another one. That kind of situation.
Whatever signal it is, you can any signal can be represented as a combination of sine waves.
I'm just like
That is the reason.
superimposition.
Yes. If you see, this is actually two sine waves superimposed on over each other.
Superimposed on each other.
Yes. So any sine wave you can represent it by the sum of sine waves or the sum using sum and subtracted values of sine waves. Even if it is an ECG signal or any signal, it can be represented using a sine wave. And you can model it using a sine wave. So that's the reason why we are studying sine wave. Okay.
Yes, ma'am.
Yes. And this
Excuse me,
50
ma'am.
hertz signal will also be coming as a some wave that it will be having some representation, but that can also be modeled using a sine wave, but it will not be coming alone. It will be also be having that other components. So this will be a 50 hertz plus 100 hertz component plus 150 hertz components and so on.
Excuse me, ma'am.
Yes.
This adding is Fourier transform, right?
No, okay. Fourier concept is another, uh, like what can I say? Yeah. If you apply Fourier transform here, here it is time with respect to the voltage, right?
Yes,
In
ma'am.
Fourier transform, it will be frequency with respect to the number of points. So here x-axis will be turning into frequency. So at 1 hertz, how many points are there? At 2 hertz, how many signals are there? And at 3 hertz, how many signals are there?
Yes, ma'am. Yeah. Ma'am, but in both cases, it's just linear adding, right? Like it's linear combinations.
Ma'am, just like we add displacement equations of sine wave, that way only we can do using sine A plus sine B type formulae.
Yes, ma'am. That's what I meant.
Superposition.
Yes, ma'am. Superimposition of waves using that equations.
Okay, yeah. I hope your doubt is cleared, or is there any other doubt you have?
No, ma'am. It's clear. Thank you.
Yes. So the next topic which we there is electricity consumption at home. What is the unit we measure at home for electricity consumption?
Kilowatt.
Kilowatt hour.
Kilowatt hour.
Kilowatt
Yeah,
hour.
one unit.
Kilowatt hour.
Yeah, it is kilowatt hour. It is basically power into time. The device which I am using, how much power it consumes, versus also considering how much time I'm using the same device. So considering these both, that we take it as power into time, which is actually energy, right? So if you want to find the electricity consumed, so you will be multiplying power, then time, then number of devices you are using, and in this time you will also be considering the number of hours per day, the number of days you are using, and how many months you are using. Okay, those all comes under time
Total value.
into duty cycle. And what is the duty cycle?
Number of times the appliance is running.
No, not exactly. Okay. Duty cycle it will be given in 0 to 1 value. Okay. Usually it is represented as percentage. That is T on divided by T on plus T off into 100%. If you are using a AC, okay. So what it does is it will be in complete on till your room cools. Okay. Once your room attains a certain temperature, then this will go to an ideal state. It will be consuming only less power. Okay. And
Ma'am,
it
the
will be
y-axis represents power.
the x-axis represents power. Yes, y-axis represents sorry,
Okay.
x-axis is time, y-axis is power. And it will
Excuse
be
me, ma'am.
yes.
Please, can you go through duty cycle once again?
Yeah, what I was saying is, see, if it is fan, it will be if you switch on the device, it will be going on continuously running till we switch it off. So for the duty cycle is 100%, okay, or one. But what about some devices like this AC and fridge? Uh, this AC and fridge, how it will operate is once you switch on the device, till the necessary temperature is reached, it will be giving full power. It will be utilizing its whole power. But once the temperature is reached, the temperature is maintained, then it will just automatically go to an very less state and it will be running. Once if someone opens a room and then there is that cooling like there is heat entering inside, then again this AC will switch on, and once the temperature is reached, again it will go down and it will be operating in this stage. So the power is not always 100%. If this device is some 2k watt hour 2k watt, it is delivering 2k watt hour power, for example, it is not delivering 2k watt always. For some instant of time, till the temperature is maintained, it is at 2k watts. Then it is going to an ideal state where it is only 100 watts. Then again, once the temperature, if it senses the sensor in the AC, if it senses that the temperature is not up to the level, like if I set the AC at 24 degrees Celsius, so till initially my room temperature is at 28 degrees Celsius. Okay, from 28 degrees Celsius to 24 degrees Celsius, till it reaches this value, it will get full on. Then once the 24 degrees Celsius is attained, okay, it will just go to the rest state. Then after many time, due to the uh, uh, heat entering through the window or through the door, due to some people entering like that and will happen, no? The temperature again it will raise to 26 degrees Celsius. Then again this will on till it reaches 24, it will be working in full power. Then again it will go down. So what the main concept is, this AC is not at its 2k watt hour always.
Means not
Only
uniform.
when need. Yes. So it is a total on is only for a certain period of time. Then after that it is in off. That we call it as duty cycle. We have to consider this factor also, right? While we are calculating our electricity consumed. So in order to introduce that term only, we have introduced the term duty cycle.
Ma'am, hello.
Yes.
Ma'am, just a question, ma'am. Ma'am, this duty cycle which you are telling, T on and T off, ma'am, this AC or fridge, this thing is used from is before also these things were used, like if the temperature comes in a particular means the temperature comes in what to say, ma'am? Means, does it control like if required temperature comes, then ma'am it
Yeah, right.
controls and it is switched off.
Yes. What does a AC do? It is basically removing the heat from the room, right? Using some mechanism, it is removing the heat. So initially my room is at 28 degrees Celsius. Then I am setting the temperature at 24 degrees Celsius. So what does it do? It is removing the heat such that it will reach 24 degrees Celsius. But if my AC is doing the same work till the end, what does it do? It will completely remove all the heat and it will be going on decreasing. So what it will do, once it reaches 24 degrees Celsius, it will stop working. And there will be a sensor in ACs also that will detect the temperature. And once the temperature rises again, it will switch on, bring it back to this temperature.
Okay, okay. Yes, ma'am. I mean, I was just asking that the old devices which were there, say, they had also the same, means the same power
Yeah,
or
sure.
same design.
Hmm.
They had some sensors which used to switch off and switch
Yes,
on
yes.
depending on the temperature. Right?
Excuse
Why?
me.
Before and all, they'll be using cooler only, right? That's
Yes,
if
ma'am.
you
But
if you
if a
sit in
certain
before.
temperature comes, then it switches off, right?
It is not switching off. It will just go to its ideal state.
Yes, yes,
Like
yes, I know.
less.
Why do we need
Excuse
a duty
It
cycle?
will go in power
Yeah, that's what I
efficiency.
explained, right?
No,
You
no.
have to consider.
When we have the power function, which is going to change anyways with respect to the time,
Uh,
why do we need a separate thing like duty cycle? Number of devices makes sense. Power function will change with respect to time. So why do we need a separate factor
this
like
power
duty?
is actually the average power, and the average power they will calculate for when the device is completely on. This power will be actually see if you take a device. If you take your mobile charger or whatever device you have, there will be a power mentioned in the back of your that sheet, right? That how much power it will consume.
Yes, ma'am.
That is
Yes,
a
ma'am.
single value. Okay.
So no one is sitting and measuring power lively. It's not real time. It is simply taken average, and the duty cycle
Yes.
is what does the work like in some sense.
Ma'am, in the graph that you have drawn, in the on means the first horizontal line that you have drawn and the second horizontal line, in both cases the AC is in on position only. There is only the power difference. The
Mm,
first case is that it's maximum power. Second case it is some adjusted value. So in the
mm.
equation of duty cycle T on, will we consider both the times or only the time when it was
No,
at its peak value?
this will be considered as T on, and this is considered as T off
Okay, ma'am. Means only the maximum peak value will be considered T on.
because it
Okay,
is
ma'am.
on throughout the time.
Okay, ma'am.
It is just a representation. You can use another variable also.
Okay,
Then
ma'am.
the
Okay.
T, then the T on is it in watts, ma'am, or kilowatt?
It is a time, right? It is time. The time during which it is on and time during which it is off.
In
Is it in
hours.
maximum power or minimum
But the
power?
power is also decreasing now, ma'am. During T off,
See,
the
this
power is
is
there.
just a simple representation I am saying. I am not telling this is the exact formula. There will be other parameters also. This is considering this ideal is approximately equal to 0.
Yes, ma'am. This actually shows that for the how much time that highest power was used. That average power that is mentioned at the back.
Okay, ma'am.
Okay.
Then this power duty cycle also happen in fans also. Na? As in starting, it
No.
requires very high
Fan.
ampere of current,
You're asking
and
about
later
fans, right? In fan, if you switch on the device, it will be running continuously only, right? It doesn't have any sensor. It doesn't reduce the speed accordingly, right? It is just running at a certain speed, depending on what speed you give.
no, ma'am. I
So,
was saying that initially when we switch on the fan, it requires very high ampere of current, which is supplied to capacitors and others. But
can you
later
please
on,
put your doubt in the chat box? Your voice is little bit not clear.
Ma'am, hello.
Yes.
Ma'am, but I'm not understanding, like, if already electricity consumed, the
Hmm.
units are power into time, then why are we including this duty cycle into this
See,
duty cycle
okay.
and this number of devices, ma'am? Because what is the need
Okay.
of that? Because already we are getting the power in the time.
Others can do this question. I'll just answer your question. Okay. See, uh, you are paying money, okay, for your electricity bill. If you see the fan,
Yes.
there are only two states. It's either on state or off state. If you switch on the fan, it will consume, I will take 200 watts. If you switch on
Right.
the, uh, if you're off, it will be consuming 0 watts. And this 200 watts you will multiply with the time you are using the fan, right?
Right.
But when you consider the AC, you will switch on the device and you will switch off the device. If you switch off the device, it is off state and it will be consuming only 0 watts. But if you switch on the device, it is consuming 2 kilowatt hour. Okay, but
Yes.
depending on the temperature, it is adjusting them itself, and that will also turn off, and it will be around on 100 watts sometimes.
Okay, so yes, ma'am. So in that case, we need the duty cycle and
The
the means
whole
and the
thing will
power
be
there. That
multiplied with time. So to differentiate these two, you need duty cycle, right?
yes.
Duty cycle will be like 6.6. That means for 0.6 percentage of time, it is in 1.2 kilowatt hour. Then remaining zero point 0.4 times, it is like not that level, like that.
And we also need the time in that formula. The total time the AC is on.
That's why in duty cycle also there is time. T on, T off.
Ma'am, what if
Ma'am,
AC
exactly agree,
consumes
but I'm not
500
understanding
Ma'am,
watts?
we
that.
have solved this question.
Okay.
Ma'am, means number of devices and this duty cycle I am not because already power consumed I am writing. Power consumed equal to power into time. Sorry, electricity consumed equal to power into time. Then ma'am, means so what is the use of this duty cycle?
That's what I'm saying, right? You can't say that AC and the fan are doing the same work. The fan, it is only two states, whether on or off. But in AC, there are three states. Like it will under when it is on itself, depending on the, it will not be see. As I said, when it is on itself, it is not giving 1.2 kilowatt constantly, right? At one time, it is giving 1.2. At time two, it is giving 1.2. Then again, it is going to some ideal mode, and it is in rest state. You have
So
to
ma'am, in
consider
that
that factor also, right?
yes ma'am. So in that case, ma'am, I can only write power into duty cycle. No need of time. Ma'am. No.
But there is also on and off, right? You have to also consider this factor. So to
Okay.
consider this 1.2 kilowatt hour and 100 kilowatt, you need this duty cycle. But whether you are switching on the AC or switching off the AC, you need time, right?
Okay.
Yes. Yeah, some of you has given the answer. 15 units and 120 rupees is right. And
Yes,
why do
ma'am.
you need a number of device? If I use here one, this is a see. That's why it is given electricity consumption at home. At home, you will not be
Yes.
using one device. You will be using number of devices.
Ma'am, one doubt in this question.
Mhm.
Ma'am, here we use actually the formula 1.5 into the time in hours, that is 20 by 60 into 30, that is number of days into 8 to calculate total cost. But as you have given 1.5 in the unit kilowatt hour, so multiplying
That's
kilowatt hour again with hour produces kilowatt hour square. It should be only kilowatt. Yes, ma'am.
yes. Thank you. So as most of you has found, it is 15 units, and this
And
is
120
rupees.
rupees. 120 rupees.
Right.
Hello, ma'am.
Yes.
Yes, ma'am. As you said that number of devices, ma'am. In case of number of devices, ma'am, already we are getting the power. The power which we are inputting, it is the total power, right? Then what is the need of number of devices?
It is not the total power. See, if there is a fan, this power will have a power rating in its. This is not the power. See, in your home, there is a board, right, where you will be seeing the number.
Yes.
That number is not the power. That number is the electricity consumed units. And how you reach that units is because for a fan there will be a separate power rating. For a tube light there will be separate power rating.
Right.
Okay.
Right.
You have to consider that power rating, how much time you are switching on the device, then that how many devices you are using in your home, as well as the duty cycle. Is it clear now? I hope it is clear now.
Okay.
Yeah. Yes. There are also other minor topics like what is a motor and what is a generator. Motor is something that converts electrical energy into
Mechanical energy.
mechanical energy. As well, whereas generator is something which converts mechanical energy into electrical energy.
Electrical energy.
Yes, but the construction for motor and generator, like basic construction, not the actual construction how it will be in devices. Like it is like a basic for us to understand. Okay, so
Yes,
there will
yes,
be a
ma'am.
constant magnetic field which will be maintained. Okay, constant magnetic field is maintained. Then there is a coil, rectangular coil, and if I pass current I,
Yes,
so
ma'am.
what happens? The electric field, the magnetic field, and the direction of the propagation will always be perpendicular to each other, right? The B and I are perpendicular.
Yes,
So
ma'am.
the direction of propagation will also be perpendicular,
There
but
will
it
be a
is fixed
force,
across, so it will rotate, start rotating.
and force will work actually.
Yes, the force will work in a direction that is perpendicular to both the current and
Both.
the magnetic field at any point of time. So, and the coil is also fixed if it is fixed in the middle. So, what will this coil do? It will start rotating.
Rotating.
So, by passing current, that is an electric energy, the coil is rotating. The rotation is a mechanical energy, right?
Yes, ma'am. Yes,
In the same way, if there is a magnetic field and I have a coil, if I rotate it, what happens?
electromagnetic induction. Flux changes as a result. Current is produced.
Yes, right. And here there are some important units, that is theta of t, omega naught t. What is the relation between these three?
Omega naught t is equals to theta of t.
Yes, angular velocity will be, as you know, velocity is equal to displacement by time. Angular velocity is equal
Yes,
to
ma'am.
angular displacement by time.
Time.
That is omega naught is equal to theta naught of t by t. So theta of t is equal to omega naught t. Then there is magnetic field. There is a coil put perpendicular to that. There is a small area dA across which the magnetic field is flowing. Then what is the magnetic flux through the coil?
BDA.
B dot
Cos,
DA.
Yes.
ma'am, for cos phi
By
is
given
1
the day.
because phi is 0. So it is BDA. Closed integral.
Yes. So since it is a dot product, it is BA cos omega naught t.
T.
So this is a magnetic flux, that is phi. Then EMF is equal to minus d phi by
Plus
dt.
d phi by dt. Minus and
So
d
that
phi
will
by
be
dt.
BA omega naught sin omega naught t. So we would have just covered the basic formulas here. We will not be going much here.
What does flux really mean? Like,
Um,
And total number of magnetic field lines passing perpendicularly through a surface.
Area.
yes, 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 right.
but how
Did
does
you understand?
multiplying a field into area gives you the total passing through? I don't understand that. You're
And
just
because
See,
multiplying.
there is a concept of solid angle while measuring flux that comes from the dot product. If we take that, we will find the total number of field lines we are actually
No,
measuring
but
because
field lines are infinite, right? There is no finite field lines.
that's why we have
field lines are
integrated.
nothing.
Like
Yes,
you
ma'am.
know how much
Integration.
like
So,
like
hello. Think of it like a rain dropping from the sky, and you took a bucket and trying to collect the rain. The
what?
raindrops are infinite. Raindrops are infinite. But if we keep the bucket in perpendicular direction with the rain, you will hold more water. That's the more flux.
But what's
But
the
if you
difference
tilt
between
it,
EMF and voltage?
like think of it, okay, that comes from Faraday's law. That is another topic. That comes from Faraday's law.
Yes,
Ma'am,
EMF comes from Faraday's
ma'am,
law.
field lines are
We gave
actually
it here.
imaginary
Yes, field lines are imaginary, but magnetic field is happening there.
happening there. Actually, it is an notation for force
Uh,
only. How much field is there? Representation.
yes. Then we'll be also having microphone, how microphone works as well as how a speaker work. How does they work? Can someone explain? Can anyone explain? One person can explain how microphone works.
Yes, ma'am. Ma'am, for a microphone, there is a diaphragm which it is connected to a coil, and the coil is kept in a magnetic field. When a sound wave hits a diaphragm, then diaphragm pushes the coil downwards so that it moves in magnetic field up and to and fro direction.
Yes.
Due to this, electronic signals are created, AC signals.
Yes, right. Then how does
Speaker
a
is
speaker
proper.
work? Can
Speaker
anyone
is
tell
proper
some
function.
other person?
Speaker is the opposite of the microphone. Like when current flows through a coil, like time varying current, AC current, at that point, a time varying electric field generated across the coil. That coil interact with the magnetic field. That's why like it vibrates. It produces a force. I think Lorentz force that for I forgot the name. It creates a force because of which it vibrates the diaphragm.
Yeah, right.
And for speaker, there is actually constant compression layer fraction of the medium, which causes the frequency due to the forces.
Thank you. Yes. So yeah, that's all. Those are the main concepts given in week 3, right? I think I have covered almost all the topics discussed. Uh, yes. Now we will have the open doubt session. Okay. You can put the question number in the chat box, or
Question 4.
you can raise your hand so that we will follow some order, so that everyone can ask their doubts. Yes. Yes. Okay. I'll call.
Ma'am, will there be any test today at the end? Surprise test?
No. No. No.
Okay, ma'am.
Uh, oh, who is that? AC.
4 graded 2.
Uh, Question number 4 of graded assignment 2, right?
Yes.
Question number 4. Maybe you can ask me practice assignment because Wednesday your TA will discuss graded assignment solutions. But still, okay, no problem. I will discuss this. Okay, I can't copy paste. Okay. Yeah, so the question says the current in a coil, question number 4 of graded assignment 2. Current in a coil increases linearly from 0.4 ampere to 1 ampere in a duration of 2 seconds. Then during the voltage across the coil is 60 milliwatt. The inductance across the coil is what? What is the formula that relates all these? V is equal
LDI by,
to I by T.
LDI by dt.
Okay, here they gave the change in current. They have also given the change in time. So that will give me 60 milli is equal to L. Change in current is 1 minus zero point 0.4 divided by dt is 2. If you solve, you will get the answer.
It's some range, no? It's the answer is some range, I think. It's weird.
If you solve this, you will get the answer in 200, I think. Yeah, the answer is 200.
Ma'am, should we not consider the negative sign of voltage here?
No. They have asked the inductance, right? Inductance is not a negative value.
Okay, ma'am.
We'll go to the next doubt. Johnny, you can ask it out.
Yes, sir. I have in doubt in graded assignment question number 3.
3. Okay, yeah. Okay, the same question which we I indirectly gave too many hints in the last class. 6 volt is connected to 3 ohms, and this is connected here to 3 ohms. Then here there is a 12 volt. Then again there is a 12 volt. Then there is a 2 ohm. There is 10 ohm. and we have to find potential across A and B. Okay, so potential across A and B is equal to voltage across this 3 ohm plus voltage across this 12 volt resistor plus voltage across this 2 ohm resistor. So this current is flowing in this direction, plus minus, whereas this one is flowing in this direction. So this plus minus. Then what is the voltage across the 3 ohm resistor? That is I into R. I into R. R is 3 ohms. I is V by R. That is 6 divided by 336. That is 3. 3 volts. So this is 3 volts. This is 12 volts. And this is, uh, there is 2 ohms, 10 ohms. Then it will be 2 volts.
Ma'am,
So
6
if I,
by 3.
6 by 3. See, 3 volts, 3 volts. 6 ohm will get divided equally.
Okay, okay.
So A, and my sign is important. Minus plus 3 volt
Yes,
plus
ma'am.
minus 12 volt, then plus minus 2 volt and B. And
And
I'm
12
going to find
are in
VAB,
assistance.
VA to VB. I can apply KVL here. That is VA plus 3 minus 12 minus 2 minus B is equal to 0. VA minus VB is equal to 12 plus 2 minus 3. That is equal to 11 volts. VA minus VB is equal to VA. 11 volts. Yes. Right? Any doubt here?
Yes, ma'am. One doubt.
Mm.
Ma'am, please can you show the circuit once? Ma'am, in that complete branch where the 3 ohm resistor is there, that branch is having 3 volt potential difference.
Mm.
So that belowmost point, if we write 0 volt, then A will become minus 3.
Here you're going to put 0.
Yes, ma'am.
Why will you put 0 here?
Ma'am, just for assumption.
Assumption, okay, fine. But
How is
still,
it possible from A to B without a loop? KVL will work only if there's a loop, right?
yes.
So
Okay.
point A and B is not a
KVL,
loop, I think.
okay. See, it is, how can I say this? It is like I'm
But
applying
that is
over a line.
No,
Uh,
when I learned the definition of loop is to come back to the
see,
same
yeah,
point
yeah.
only one time
See,
without
how I
repeating.
assume this.
Then we
At
can
this point,
apply
this,
KVL
yeah, one
from
second, please.
point to point also.
This is A, right? This VA I am considering A with respect to ground, and VB I am considering with respect to ground. So somewhere the loop is closed, right?
Ma'am, but in the figure, the loop is not closed from A to B. How can we apply KVL? Means how
But
will
if I
we
suppose
return the
VA,
current?
but are you not
see, voltage
considering
is a
B as
potential.
ground?
And ma'am, no current flows through the 2 volt battery, 12 volt battery. So how can we apply KVL there?
See, wait. What I'm saying is, what does VAB means?
So does it mean we have to imagine like a ground
VA
connecting the
minus V.
ground, something like that?
VAB is the potential difference between A and B, right?
Yes, ma'am.
But if I say potential at a point, what does that say?
That will be VA in that case. That is the energy to bring
VA
from
is with
infinity.
respect to ground.
Yes, ma'am.
Potential, see, what is potential?
Ma'am, it is the energy required for a unit positive charge to make it from infinity to that point in an unaccelerated motion.
So there is a potential here. Let it be VA. Let it be VB. If VA is greater than VB, that is the potential at A is greater than VB. So current is flowing in this direction. That is, this VA is having a higher potential and VB is having a lower potential. So the charges are flowing in this direction. Right.
Right,
Now,
ma'am. Right.
so okay. Now, if I say just VA, that VA is actually the potential with respect to some ground. So potential is not always a single value. It is a with respect to reference only we will give potential.
Ground with respect to ground.
Since I am taking this VA value, I just assumed it the ground there.
Yes, ma'am.
Even though in this question they didn't specify there is where there is a ground, but it doesn't mean that it is no ground.
Ma'am, I solved it by
Also,
KCL. It's even easier.
yeah, you can solve by
Yes,
using.
ma'am. With KCL, it's a bit more easier than this.
Ma'am, we can solve like linear equations VA minus VB equal to 3 volt like that.
VA minus VB is equal to 3 volt.
Writing equations and eliminating.
Ma'am, what we
Ma'am,
can
you
do
can
is write
assume, ma'am, you can
equations of
assume,
loops independently
As
and
long
then
as you do any method and if you get the right answer, then it is fine, right? Yeah. Yes. Any other doubts? Please go to the next
Ma'am,
doubt.
ma'am, question number 10,
Um,
please.
ma'am,
yes.
if
One
potential
quick question.
VB greater than VA, so answer will negative.
Negative. Yes. If VB is greater than V, your answer will be negative.
Ma'am, can you please provide the summary of the solution you did?
Okay. One second. You can just take a screenshot. So this is a circuit equation. This is the general equation. Then this is the equivalent circuit, and this is the solving. Shall I move to the 10th question?
Ma'am, ninth or tenth question also.
10th question will solve. Okay. Okay. Why is that a problem? Because see, there is a 12 volt, there is a 2 ohm, there is a 12 ohm, there is a 3 ohm, there is a 3 ohm here, then here there is a 10 ohm, and here there is a short. So basically, no current will flow here.
Bypass will be there, current bypass.
Mm. You have to find I. One second. Yes, yes, sorry. So yeah, we have to find I, which is flowing here. So I is basically flowing here, here, here. So if I just draw the equivalent circuit, 12 volt, something like this, 2 ohm, and across this there is 12 ohm, and across this 12 ohm there is 2 resistor, 3 ohm, 3 ohm.
So total 6 ohm for 3 plus 3.
And you just have to find the total current. Current is equal to V by R. V is equal to 12. Find the equivalent resistor. This is 9. This is 12. So 1 by 12 plus 1 by 9. Uh, the whole
And
inverse.
how are the two 3 ohm resistors are in series? There is a wire going in between them.
I told you, right? There's no current flowing there because this is practically a short. If there is a
Yeah,
short
but
and a
but that wire in which 12 volt is connected.
12 volt is connected there, right? See,
Yes,
this
ma'am.
is a node B. This is a node B. Between A and B, there is a short as well as there is a resistor. And through the resistor, there will be no current flowing because this is basically a short. Okay?
Ma'am,
Mm.
ma'am, in question number 3 once, can you show once more?
Question number?
3 means the previous question that you solved. Ma'am, there as I was telling that for that branch containing the 3 ohm resistor, as the A point is at lower potential with respect to the last point, means that one where you have written plus. So if we take the plus point as 0 volt, if we assume, then the A point will be minus 3 volt, so that the potential difference will be 3 volts.
Why are you doing that first? I'm not understanding the context.
Ma'am, that point which you have, just like ma'am, if we have a potential difference of 3 volts, we write it in the format one end is 3 volt, another end is 0 volt, in order to
Okay.
make the total potential difference 3 volt.
Here actually the 3 volt The zero reference. Okay, if you want to draw this in another way, I can draw it actually. Wait.
Yes, ma'am.
Okay, I can't copy it. There should be some way. Oh, yes. Yes. Okay. Okay. See, here there is no ground. Ground is at 0 volt, right?
Yes, ma'am.
And here it is not connected. And they are not given ground also. So I don't think you have to be so concerned about the ground in this question.
Ma'am, but just as in nodal analysis, we assume that the potential at the that is a node reference potential. We assume that there is grounding.
Then here you can assume only one point, right? You have to assume here or somewhere, or you can assume here, but there is only one node point. It's
Okay,
like
ma'am.
practically saying like you can't assume 2 points. Here also you can't assume, and here also you can't assume. That's what I'm trying to say. And
Okay, ma'am.
also, if you see through this branch, there is no current flow.
Yes, ma'am. That is only I'm telling. Through that branch, there is no current flow because
But
that will
potential
not
exists.
be part of its circuit.
Mm.
Then I have another doubt, ma'am.
Excuse me, ma'am.
Yeah, just pose a question number, no?
Ma'am, the question number 10th you were solving. Ma'am, the two 3 ohm resistors, I have doubt that when two resistors are in series, they are directly connected to each other and they are in series. But when between these 3 ohms and between the points A and B, there is one 3 ohm resistor, then one loop in which 12 volt is connected, and then another 3 ohm resistor. So how these are
Okay,
in
wait.
series, not directly
You first name the nodes here. That is it is C here and it is D here, right? And 12 ohm is connected between C and D, not between A and B. And the short is between A and B, and this resistor is between A and B. So this I am cancelling. And also, uh, if you combine these and this, uh, okay. If current is not flowing here, I will just open circuit it. This branch I am cancelling. Okay. Now if you see, what do you say? 3 and 3 is in series, right? And 3 and
Yes,
3 are
ma'am.
in parallel with 12.
Yes, ma'am.
Okay, okay. And another one important concept I want to tell. Yes. Okay. For now, we will just have resistors and that sum. Okay. Not a resistor, maybe a wire. When will the current be zero?
when
When
the
the
When the
delta
current
V
will,
potential
across the wire is zero.
if
Uh,
the potential difference is zero.
if I want
potential
to
difference is
model
zero.
I is equal to zero, what will I do? I will just use
Then
an open circuit such
yes,
that the
ma'am.
I is equal to zero. There is no current flowing here because it is not connected. But if I want
Yes,
to
ma'am.
model P is equal to zero, what will I do? A
Ma'am,
and B,
either the resistance can be zero or current can be zero.
VAB is equal to zero. That means
Cross the
voltage
wire
A
or
is
connect
equal
the
to
wire.
That is VA equals to VB.
if it is shorted,
Potential difference are
voltage drop will be
same.
equal to zero. If it is open circuit, then it is a current is equal to zero. This concept is clear, right?
Yes.
Yeah.
Yes, ma'am.
Then,
Potential
ma'am,
difference
can
same.
you once again explain, ma'am?
Yes. There are two cases. The current flowing through something is zero, and the potential drop across it is zero. There is
Yes,
a
ma'am.
point A, there is a point B. Okay. When will the current be zero? When it is an open circuit. That is basically there is no connection between two. Only then the current I will be equal to zero. So in there is a circuit. If I want to say I is equal to zero, I will just practically open circuit is telling everyone that I there is no current flowing there. So it's basically even though the component is there, the current is not flowing. Practically is a open circuit. There is no connection between A and B. If voltage drop is equal to 0, the voltage at A is equal to voltage at B. When will voltage at A will be equal to voltage at B? When it is both connected.
Both points are
That's
in
it.
equipotential.
Modeling of current. Okay. Equivalent circuit. This
Okay.
one is the equivalent
Yes, ma'am.
circuit.
Yes, ma'am.
Question
Okay,
number
ma'am.
11, madam.
Question number?
11.
Okay. 11, no. Anyway, next Wednesday. Okay, next Wednesday we'll solving week 3, I think. Yeah. In question number 11, what is the question? Uh, there is a graph like this, and from 0 to 2, you have to find the voltage across a capacitor, right? This is
Yes.
I of t, and you have to find B. B is equal to Q
Integration
is
1
equal
by C I dt.
Q is equal to CV. dq by dt is equal to CV.
C dV by dt.
Sorry, d by
dV by
dt.
dt will be there.
I is equal to C dV by dt.
dt.
Whereas
Okay,
V
but
is equal to 1 by C integral I dt.
That is the area
So
under IT.
yeah, you have to just find the area 1 by C integral I dt from 0 to 2. This is basically area under the curve. If you put this in the equation, we'll get the answer.
Madam, the initial voltage is given as 0. So will that not come as negative? Ideally, if the current is falling, the voltage should be negative, no?
Where is current falling?
Yes.
Current is constant.
Current is constant. The reason why they are given the initial voltage across the 0 is
If we remove integration, there will be a V2 minus V1. V1 will be 0.
only if it is initially it is 0, we can use this formula. That's why. There is this
Yes,
concept
ma'am.
called charging and discharging, which we will be learning in week from week 7 and week 8. That time we will be understanding it more.
Okay.
Like most of the
Ma'am, question
capacitors.
number
Question number
9.
9. Voltage across a 5 ohm resistor.
Yes, ma'am. 9.
Okay. So this is 5 volt. This is 10 volt. This is 2 ohm. This is 5 ohm. This is 3 ohm. If you put this, the voltage drop across here will be 5 volt. And this here, the voltage is 0. And if you see here the voltage drop will be 10 volt. Here it is 0. So the voltage difference is 0. Is it clear, or do you have any doubts here?
Okay.
Just apply loop, find the voltage across the resistor. You will see this voltage and this voltage will be equal, so there will be Gaurang Shri Vatsava. Yeah, what is the issue, Gauru? You said you can share screen. What happened? You want to share your screen?
Ma'am,
Okay.
we can
Question
do
number
this question by KVL also.
Question number 10 I have explained already. Ninth, okay, done now.
Ma'am, hello.
8. Yes.
Ma'am, just one time, can you tell the twice the voltage both sides 0 here?
Yes. See.
5 ohm resistor.
Okay, we are going to find the voltage at this point. This voltage rise is equal to this voltage drop. So basically there is no voltage here.
Okay.
Ma'am, can we prove it by KVL also?
KVL. I think I used here KVL. Here potential increase is equal to potential drop. And also see, what is the I here? What is the value of I here? By seeing the circuit, you can find I, right? See, this circuit and this circuit are not connected. Uh, Current will flow only in a closed loop. But here, there is loop here, there is loop here. And the current entering here has no pathway to turn. So this current is zero. So I across the 5 ohm is 0. The voltage drop across the 5 ohm is equal to I into R. If I is equal to 0, the potential across the 5 ohm will also be 0. In the previous question, there was a potential there. That's why even though I is 0, there is a potential. And here there is a current, that's why there was a potential here. Here also there was a current, that's why there was a potential here. And here
Ma'am,
there
in
is
this question, the I was 0 because from the both the loops, the same current 1 ampere was flowing from both sides. So they cancel out each other.
no, they are not cancelling anything each other. What I'm saying is, when will a current flow? The current will
Ma'am,
flow
no,
when there
not
is
in
a
this one,
closed
in
loop.
the previous one.
In the previous one also, current will flow in this inside the loop. It will not flow here. Here the current will not flow because there
In
is no
every
returning
case.
path.
Ma'am, in every case of resistors and it will not flow in this branch.
If there is a circuit like this, then current will flow. If I give the same circuit like this, do you think current flows in the circuit? What is the current flowing through the resistor?
Zero.
No current
Zero.
will flow, ma'am.
Current will not flow through an open circuit.
Yes.
That's why I said to model a current I is equal to 0, we just open circuit it. So if it is an open circuit, then there is no current flowing. What is a current flow? It is a movement of charge. If there is no connection between them, how will the charge move? Right?
But ma'am, in the previous question, it was not the open circuit for the 12 volt or it was?
12 volt. It was an open circuit. And here, but the 3 ohm is not an open circuit. It is inside the loop. And here the 2 volt is inside the loop. Only the 12 volt was in the way. And here we are not finding the current. We are probably finding the potential.
Okay.
Yes. Can you please ask the remaining doubts in the next class because it's already 8-7. Or is there any doubt you want to ask? You can ask. Otherwise, you can leave the meet. If you don't have any doubt, you can leave. Otherwise,
Can you
Ma'am, can you
Ask
explain
some
the
doubts.
separate questions?
yeah. Can you please tell again what happened?
Ma'am, can you explain last surprise quiz questions?
Last surprise quiz questions. Okay, what are the questions?
No, ma'am, I have no idea.
Oh yeah, I will check. Wait. One second.
Ma'am, question number first and second.
Yeah, one second. Okay, I think this is the one. This is a question, right?
Yeah, ma'am.
The voltage across the 2 ohm resistor. Nice. If you see, my arrow is visible, right? There is a 8 ampere going this way in this branch. Apply KCL at this node and find the current flowing through this node. What is the current?
8 ampere. 8 ampere.
Wait. 8 ampere is coming in this branch and 8 ampere is going through this branch.
Ma'am, no current will be flowing, na?
Yeah, then it will be 0, right?
because already
Ma'am,
they
but
are getting a easy way out.
options not match.
Is this a question asked in the last class?
Yes, ma'am.
Okay. Okay, I will check this question, okay? It
Okay,
should
ma'am.
be 0.
Yeah, ma'am. Zero answer.
Yes, ma'am. So it is
How
written
come
-8 here. Minus 8.
the both currents are different, man?
How come? In the branch it is 8 ampere, here it is 8 ampere, in the middle branch then it should be 0 ampere. Then only the KCL will be satisfied.
Okay, ma'am.
Then the voltage across the two. Okay, I will
Ma'am,
check this,
isn't
okay?
-8 fine, ma'am? -8 isn't it fine?
We are asking the voltage across a 2 ohm resistor, right?
Okay, okay.
There is no current flow through the through
Yeah,
2
yeah,
ohm
right, right.
resistor. I
It
is
should be
equal to
0.
0. So V is equal to IR. That is also 0.